Now, for the last couple problems here. All right, so again, first thing I'm going to do is I'm going to find the two solutions on one cycle of cosine without changing the period. And again, negative square root of 2 over 2 is a ratio on the unit circle that we should know. So I'm going to go to my unit circle. Where is cosine negative square root of 2 over 2? It's going to happen here and here. And these angle measurements are 3 pi over 4 in radians and 5 pi over 4 in radians. So find those two solutions. Okay, next step, I'm going to set them equal to that bx on the inside. So I'm going to have pi over 2 times x equals 3 pi over 4, and pi over 2 times x equals 5 pi over 4. And then I'm going to solve each one of these little equations. So what I'm going to have here, when I solve this, I'm just going to multiply both sides, or you can divide both sides by pi over 2, or multiply both sides by 2 over pi. So what I'm going to get here is 3 pi over 4 times 2 over pi, which in this case reduces down to 3 halves. And my second solution is going to be 5 pi over 4. And again, I'm going to multiply both sides by 2 over pi. So I get 5 halves. So there's my two solutions on one cycle. So now the last thing is, to get more solutions, I have to add on the period. So the period equals, just like the beginning part of the chapter, 2 pi divided by b, which is pi over 2. So our period is 4. So to get more solutions, add 4 to get more solutions. And again, if I want to write that as an expression, I'm going to write it as x equals 3 halves plus 4n, or 5 halves plus 4n. All right? All right. Now for the third one. This one is definitely a calculator problem. So I wanted to do one calculator one where we were messing around with the period. Okay, so this one takes a little bit more work. Okay, so what I'm going to do, again, I want to find the two solutions on one cycle of tangent. Okay, so to find that first solution, what I'm going to do is I'm going to go inverse tangent of 3. Okay, and what I get when I do that is 1.24905. Okay, which is right about here. The other solution for tangent is going to be directly across, so that other solution is going to be 4.39064. Okay, because I'm going to add on pi. So again, to find the 4.39064, you're going to take 1.24905 and add on pi. Okay. Now, to find more solutions, we add. So now I'm going to take both of those solutions, set them equal to 2x. So 2x equals 1.24905. Okay, and 2x equals 4.39064. So this x value is going to be 0.6245. This x value is going to be 2.19535. Okay, now these are my two main ones. To get more solutions, you add on the period. Okay, so my period this time. This is the one little tricky thing about tangent. Tangent's original period isn't 2 pi, it's pi. So to add on, to get more solutions, I'm not going to go 2 pi over b, I'm going to go pi over b. So I'm going to go pi over 2. That's the one thing that's a little tricky about tangent. So my period's obviously just pi over 2. So to get more solutions, add pi over 2. So again, the way I can write that x equals 0.6245 plus pi over 2 times n. Now, the one nice thing, just like the previous one, if you take a look at these two answers, they're actually pi over 2 off. Okay, so you actually don't have to write that second one plus pi over 2n, okay, because they are exactly one period off. So 0.6245 plus pi over 2n, where n is an integer. Now to finish off, we actually have one more quick example, and we actually did something similar to this the other day. And I'm actually going to skip part 3, and you can skip those associated problems on the worksheet that goes along with this section. Okay, so part 4. This was actually a problem in one of your previous worksheets, and I'm actually going to start off with what the answer was. So again, in the previous section, we took a situation, we came up with an equation. So here's the equation for that situation. But now my question is, foxes are declared an endangered species when the population drops below 300. Okay, so between what two non-negative values for t did the foxes first become endangered? And this is what I'm going to tell you to do. This is a pretty complicated question to, or a pretty complicated equation to actually solve for t. So we have tools. Let's use those tools. And actually, you could have used this similar process on some of the previous problems too. What I want to do is I want to find out when the population is 300. So this is the equation I'm trying to solve. Okay, so instead of going through and trying to do all this algebra, let's grab our graphing calculator. We have it, let's use it. It's a great resource. Okay, so what I'm going to do is I'm going to go to my y equals screen. Okay, I'm going to plug in that equation. Again, make sure your mode's in radians when you do this. Okay, and then I'm going to graph this thing. The toughest thing about this is probably figuring out the window. So what I notice is my vertical shift's 500, my amplitude's 300. So the highest point's going to be at 800, the lowest point's going to be at 200. So I'm going to make my y min and my y max 0 and 1,000 so I completely cover that. And then we can go up by like 100 or something like that for my scale. Okay, now what I notice is my phase shift is 2.9. And if you actually look back, your amplitude is 22 divided by pi. Or sorry, 22 divided by 5. So what I'm going to do for my x-min and my x-max, I'm going to go from 0 to, let's say, 20. Okay? And then if I choose a good graph, okay, or if I choose a good window, I can come up with a good graph. Okay? And now from here, I want to find out when the population drops below 300. So I'm going to go back to my y equals screen. I'm going to put in 300 as a horizontal line. Take a look at the graph, and you can start seeing points right away. Okay, where the population drops below 300. So notice between, or okay, that first little interval where it's below 300, that's the first one I'm looking for to answer this question. Okay, and then to answer the next question, notice I can easily see the next interval on there. Okay, so what I'm going to do to find those intervals is I'm going to find the points where the cosine function crosses that 300. So I'm going to use calculate, and I'm going to use the intersect feature. And again, it's a little different on each calculator. We already went over how to do this though. They give me a cursor. Okay, so what I'm going to do is it's currently on the cosine wave. I'm going to hit enter to choose it as my first curve. Then notice the cursor goes down to the horizontal line. I'm going to choose that for my second curve. And then whatever point I want to get, I'm going to move my cursor close to it. So I'm going to move my cursor close to that first one. And I get 0.111. So my first solution is t equals 0.111. Now, all you have to do to finish that first question is repeat that same process to find the next intersection point. So again, calc, intersection. Okay, it's currently on the cosine wave, hit enter. It's now on the horizontal line, hit enter, and then move it close to that point, hit enter. And I get my next value of 1.289. So what that tells me is between 0.111 and 1.289 years is the first time period when the population will be endangered, which is below 300. And then the next interval, all you have to do is find that next little interval on there. So I already did this problem. You can try it on your own on your calculator. I found it was between 4.511 and 5.689 years. Okay, so again, you got your calculator. This will be a calculator problem, so use it wisely. All right, give the worksheet a shot. Again, you can skip any problem that's similar to part 3 on that note sheet. All right, we'll see you tomorrow.